that, what we've got here is we're multiplying, basically what's going on in this section is we're multiplying and we're dividing fractions, and then we're just simplifying, okay? So we got to remember, how did we multiply fractions in the first place? If I had, for instance, 1/3 times 7/5, didn't I multiply across the top? 1 times 7 is 7, and 3 times 5 is 15, right? But if I was multiplying, let's say I multiplied 1/3 times 3/2, can't I cancel things out if there's something on the top, like the 3? There's a 3 on the top and a 3 on the bottom. I could have canceled that one out, and it would have just been a half, right? In a lot of what we're doing in this section, in order to remember how to do it, if we just think back to fractions and what we did when they looked a little easier, it'll help us know what to do here. Now, when you look at this, what we're going to try to get to do, what we want to have happen here is we want some factors to cancel out, kind of like that lower problem I worked over here where I canceled something out. So in order to see if something cancels out, I'm going to have to factor it. So this is another one of those sections where we're going to have a lot of factoring to do. And by the way, I'm probably going to reduce your homework, okay? I'm just thinking I'm probably going to reduce it just because I'm looking at it, and I think we could cut quite a bit out and give you less problems. But we're going to do all the ones in the first section that I assigned, the 1 through 33 odd. So here we go. We got a factor. Now the first thing I see on that first one here, I'll kind of color code my factoring. Here's x cubed minus 1. And if you remember with the cubes, I had to think, what did I cube to get x cubed, and what did I cube to get 1? I knew that I needed a cubic factoring pattern because there's not anything that divides out of x cubed and 1. That's the only place I've got to go here. And if you remember, you would say it's x minus 1. And then in the second factor, which usually doesn't break down any further, it never does that I've seen, you take the first term and you square it. Because there was a subtraction term in the first factor, this becomes a plus here. You can always look up the formula, but I'm just trying to tell you how I remember it. Then you multiply the x and the 1 by each other, so that's going to be x. And then I'm going to put a plus sign always, and I'm going to square the second term, which was a 1. 1 squared is 1. Okay, so that factored that one. Now look on bottom here. I have an x plus 1. Is anything going to cancel out so far? Can't factor x plus 1 either. It's as small as it's going to get, isn't it? Let's go over to that second fraction. Let's factor all the parts of it. I'm going to do this top first. I'll do it in green just so we can kind of see, where the parts are. X squared plus 2x plus 1. That's got 3 terms. Nothing divides out of it. There's a plain old x squared. That means if this factors, this is an easier factoring problem. Yeah, you're trying to multiply to get 1, and at the same time you want the two numbers to add to get 2. And Charlotte has found it. It's 1 times 1 is 1, and 1 plus 1 is 2. So this becomes x plus 1. And I could write it as x plus 1 squared, but if I'm going to be canceling stuff out, I probably would want it listed like that. Okay. Now on the bottom, I want you to notice something first of all. I could try to factor this. It doesn't factor, by the way. Do you notice anything? Is that factor showing up somewhere else? Let me write it down in blue. I'm looking right here. That doesn't factor. There's nothing that multiplies to give me 1 that also adds to give me 1. Isn't that what I'd have to think there? Because there's 1 on the end and the middle coefficient is a 1. I can't find any numbers that would work there. I can write the little box down, but it's not going to help. It's still not going to work. But look here. Isn't that going to cancel out though? Look right here. That's exactly the same thing. I'll put a yellow line through them to show that I'm canceling them out. Those two things are exactly the same thing. Yay, they went away. Even though they didn't factor, we were able to cancel them out, which was kind of surprising. Okay? Yeah, there's going to be other stuff that cancels out. Let's see. There's an x plus 1, and there's an x plus 1. Now, I can only cancel out one set of them, right? So I have an x plus 1 left. Everything's gone off the denominator, isn't it? So what I have left is just in the numerator. It's x minus 1 that didn't go away from this first term here, and then there's this x plus 1 over here that I just circled. Bless you. That would be totally factored. Let me check and see what the book writes. The book goes ahead and multiplies those out. It doesn't leave them as factors because it just told you to simplify it. So they actually go ahead. Isn't that the difference of two squares? That would be the first term squared minus the second term squared. So x squared minus 1 squared is 1. That's what I would have left. Now, if it were me, I would have probably left it like this. So I don't care whether you leave it factored when you get finished. A lot of times that's just more helpful anyway. The reason we're doing all this is, remember how we started off graphing rational functions? And we did a little bit of stuff, and I told you later on you're going to learn some other stuff that'll make this go a lot faster. They're just trying to get you ready for that. They're kind of putting you through the reducing, they're putting you through the ringers here, reducing stuff, just so that you see how it works. Everything that canceled out here, if I had actually had a function and this were the value of the function, wouldn't everything that canceled out here give me a hole in the graph? You think back when we were graphing these things, isn't that how we determined holes? Everything that I canceled out there would have been a hole. I'm not getting any feedback, so I'm just going to go on. A division problem that you have to do. I know I did, I think I did 23 on a video, so let's pick a different one. Let's pick 31, okay? All right, so for 31, we have this. X to the fourth minus 27x over x squared minus 9. And then they say divided by x squared plus 3x plus 9. And then that's divided by x plus 3. Okay. When you divided fractions, there's a couple of ways they looked. It's actually going to show you them looking a different way here towards some of the problems in the back part of this. If I had a third divided by 2/3, you remember that you keep the first fraction the same as it is. You just leave it alone. You change the division to multiplication, and then you take the fraction you're dividing by and you flip it. You take the reciprocal of it. So 1/3 divided by 2/3, I could change that problem into 1/3 times 3/2. You keep the first one, you change the division to multiplication, and you flip the second fraction. Now, sometimes this is what it looks like. You remember these? That same problem could have been written like that. And I would have said keep the numerator, change the division to multiplication, and flip the denominator. Either way, it's the same problem, okay? The reason I'm showing you this is if you look at the very last set of problems, 47 through 61, you're going to get a lot of complex fractions, and they're not going to be very pretty. If you flip back there, you can see what they're going to look like. Okay, so if I want to rewrite this, I could keep the first fraction. I'm going to change the division to multiplication, and then I'm going to flip the second fraction, the fraction that I'm dividing by. The x plus 3 would go on top, and the x squared plus 3x plus 9 goes on the bottom. Okay, and once I do that, I can really start factoring. I could have started factoring on the first fraction if I wanted to. I was just trying to kind of keep this simple and one idea at a time at first. Okay, so let's look at the first fraction. X to the fourth minus 27x. Do you remember we're always supposed to check for a GCF? Is there a GCF in this first? Yeah, what is it? What would it be? 3. Well, x to the fourth minus 27x, there's not a 3 on the first term, but couldn't I take an x out of both of them? I could take an x out, but there's not a number in front of that x to the fourth. So that, if I factor that out, what's left in x to the fourth if I take an x out? X cubed, And then I got a subtraction sign, and I had a 27x, but I took the x out. That's going to be a 27. Oh, that's going to be a cube to go factor, isn't it? Okay. Let me go ahead and put an equal sign down here, and let's keep working on just that part. I'll keep it in green so you can follow along. Now, that's the same thing as thinking x cubed minus 3 cubed, because 3 cubed is 27. So if I factor that x cubed minus 27, I would write an x and a 3 down. Since it's subtraction, I'll have a subtraction sign here. Then I take this x and I square it. I'm going to put a plus here because there was a minus in the first factor, a subtraction sign. That means I'm going to have an adding sign here. I'm going to multiply the x and the 3, this x and this 3 that we're talking about over here. I'm going to multiply them together and get 3x. And then I'm going to put a plus sign, because there's always a plus sign in that spot. And I'm going to say 3 squared is 9. You might want to look up that factoring pattern. I'm trying to do it, just talk myself through it without having to look the formula up. Okay, let's look at the bottom of that fraction. Let's just keep working on the first fraction. What kind of pattern is this right here that I just circled in red? Yeah, it's a difference of 2 squares. What do you square to get x squared? You square x. What do you square to get 9? 3. So I'm going to have an x and a 3, and an x and a 3, and one of them is going to have a plus sign, and one of them is going to have a minus. And let me just copy that down on here, carry it along, and I already see something's canceling out, right? Then this x minus 3 and this x minus 3 cancel out. We like things that cancel out. They just are nice. All right, let's go look at the second fraction. Am I going to need to factor x plus 3? How do you know? There's no way to, if you've got an x plus something, it's already all the way down, the smallest it can get. So they're kind of being nice to you and just letting you copy that down.
You can still cancel it.
You can still cancel it, you're right. That one's going to cancel. I'm going to write it down, and then I'm going to cancel it down here on this step down here. This x plus 3 would cancel out with that x plus 3. There's one on the top and one on the bottom, so they go away. I'm going to kind of leave that middle one just where it's kind of a little bit clearer so everybody can see. What about this x squared plus 3x plus 9? Do you see it anywhere else? Mm-hmm. Look, right here, it ended up on the top when I factored that cube out. By the way, it won't factor. I could try, but there's nothing that multiplies to give me 9 that adds to give me 3, so that's not going to factor, but who cares, because it's going to cancel out, isn't it? Huh? Oh, no, we got more than that. We got that x out front, don't we?
Oh.
So if I look, this exactly matches this. Yay, they set that up that way on purpose, by the way. It doesn't just happen to happen. Only thing I got left is this x. It was the GCF that I pulled out at the very beginning, so my answer here is just x.